In this video, we're going to build upon the circuit and the flow that we set up in the previous video. In that video, we set up a switch and an LED, and the LED would turn on and off depending on whether or not this switch was depressed. In this video, we're going to take the input of this switch, and through node red and the flow, we'll simulate a push-on, push-off switch, so that when we push this switch and release it once, the LED will turn on, and when we push and release this switch again, the LED will turn off. With that, let's get started. We'll flip over to the web browser. The first thing we're going to want to do is scroll down and grab the GPIO in node. So we'll drag that out here. We'll double click this to get to the properties. Now the switch is connected to GPIO 26, so we'll select that. We're going to say we want to pull down resistor. We'll leave everything else at the defaults and click on Done. The next thing we're going to want to do is bring in a switch node. We'll drag that out here. In order to keep track of the state of the LED and whether or not it should be on or off, we'll be using context data. Now, in order to be able to read whether the context data is on or off, we have to create it first. The first thing that the switch node is going to do is look at the context data and see if it does exist or not. For this particular context data, we'll call this state. And there's going to be two conditions. The first condition will be if it's null, meaning it doesn't exist. And the second condition will be is not null, meaning the data does exist and that we can test against whether or not it's been set to true or false. We'll go ahead and click on Done. Now we'll drag in a change node. And the purpose of this change node is to set the context data if it doesn't already exist. We'll go into the properties of this context data, and we're going to set state to be false, meaning the light should be off. So again, if this variable state does not exist, we're going to set it to false, which will create it. Then we'll have something to test against. The next element we'll need to add in is another switch node, and we'll put that over here. When the pin gets set to a 1, this switch node will then react to it. So we'll double click this to get to the properties, and we're going to test for the number 1. Again, the purpose of this switch node is so that this only gets activated when we depress the button. We don't care what happens when we release the button. We only want to do something when the button is actually pressed and a 1 is sent out along this message path. So now we can go in and add another switch node. The purpose of this switch node is to look at the state of the context data state. If it's true, we'll go down one path, and if it's false, we'll go down another path. We'll double click this to get to the properties, and what we want to look at is the global context data called state. We'll check against two possible values. First one is true, and the second one is false. We'll click on Done, So now we're going to add a couple of additional change nodes depending on the state of the state context data. So if the context data is true when we check it, we're going to set this change node to make it false. And if it's false, we're going to use this change node to set the context data to be true so that we switch the states here. So we'll double click this first one. We're going to be setting global.state, and we'll set this to false. The other thing we want to do is set the message payload to be false. And this is what it will actually turn the LED on or off. So now that we have that, we can click Done. And in this change node, we're going to do exactly the opposite. If the state is false, we're going to want to set it to true. So we'll do exactly the opposite here. We're going to set the global state to true. And then we'll also set message payload also to true. And click on Done. Finally, we'll scroll back down and we're going to grab the GPIO out node. We'll double click this. We're using pin 40 or GPIO 21 as the output for the LED. We'll click on Initialize Pin State and we're going to set it to low. So that way every time we hit deploy, the LED will be off. Now we'll go ahead and click on Done, and let's wire this up. When the button is pressed or released, we're going to trigger a flow. This switch node is going to check and see if this global.state variable exists or not. And if it doesn't exist, we're going to send it up over here where we instantiate it and set it to false. We can then take the output and pull this here so then it can go and change it. If the context data state does exist, then we'll just go on to this switch node, which then checks to be sure that the pin is a 1. If it's a 0, this flow will not do anything. It will only respond when the button is actually pressed. So when a button is pressed, we'll go on to this switch node. And the purpose of this switch node is to check the state of the state global context. If it's true, we'll go down one path. If it's false, we'll go down another path. If the state is true, we'll go here to this change node, which will change the state of the context data state variable to false, and we'll also set the message payload to false. If the state is false, we'll then go to this change node, which will then set everything to true. Finally, we'll take the output of both of those and send it on to pin 40 or GPIO 21. And this is what eventually will turn the LED on or off. I'll go ahead and click on Deploy. Now let's include a view of the actual circuit. So when we press the switch and let go, the LED turns on. When we press the switch, the LED turns off. The switch itself is a momentary switch. but we've used nodes and flow within Node-RED to simulate this switch as a push-on, push-off type switch. That's all there is to this video. Thank you very much for watching. Stay creative.